Anybody know what a design pattern is? What is a design pattern? What's a design? What is a program design?
Model. A model.
Model.
Sort of.
Okay.
So it's blueprint.
Blueprint, model. Excellent answers. All right, so basically, when we design programs, what do we do when we design programs? What is the job of designing a program? What does that really mean? Go ahead. Structure it. What does that mean?
Laying out what you want.
Has to work according to the requirement.
Understandable.
Okay, there. Basically, if you think about it, we're going to write an object-oriented program. Let's say that's our goal. All right, and it's a good-sized program. It's not something trivial. It's something relatively complex. So it's going to take a little bit of planning. It's going to take a little bit of design. What are some of the things we're designing? What are some of the things that we're designing?
Objects we need.
Okay, but before we get objects, we have to design classes. So we have to design classes, so class design, right? So that's kind of what we would call a static design. We design classes, how things are fitting into each other, the pieces, right? Then we might want to design the dynamics of the program, which means how do things interact, right? So it's going to take a little bit of time to put things together. So some of them are going to be actions. How we're going to get things to interact, communicate with each other. Methods, calling methods. How we're going to create a class hierarchy perhaps. Which classes depend on other classes. What are the responsibilities of classes? Lots of things we have to design to put things together. We're going to find that sometimes some of our designs are going to require certain things to happen. We're going to need to do something. We're going to have to put something together. And all of a sudden, we're working on a program and we realize that this is a similar problem that we solved in designing the last program. And this is the same thing we did the time before. And each time we're reinventing the wheel. It means we're creating a new solution for something. And yet, we've solved this problem before. Here we are solving it again in a different way. So, design patterns are the types of design decisions or design choices we make when we see that we're actually designing very similar things over and over again that seem to occur in many programs. It happens a lot. So the question is, will design patterns make our programming job easier? Is it going to be easier for us to design our code? And I'd like to say yes. But I really can't say yes. Initially, I'd say that there's always going to be a big learning curve whenever we have to do something new, because design patterns are going to save us reinventing the wheel, but we're going to have to learn how to implement the design patterns. And design patterns usually, what they do is rather than having to implement something directly, you kind of are abstracting what you're doing a little bit. So you abstract a little bit what you're doing, but it gives you more flexibility and it gives you a lot of the sameness for similar design decisions. And that's what design patterns are. So I'm not able to get this thing to change for me automatically, so I'm going to have to walk it around. Okay. So a design pattern is a general, repeatable solution to a software design issue. It's not a finished design that can be directly put into code. It's rather a description or a template. Somebody said template or a model. I forgot exactly what you said, but you had some good answers. How to solve a problem that can be used in many different situations. Okay, so design patterns capture experiences of expert software developers and present common solutions to recurring problems and the consequences of these solutions in a sort of a methodical way. So, and again, so some of the design patterns you're going to hear words like adapter pattern. Okay, so adapter means you got to adapt something to something else. factory pattern. Well, what do factories do? They make things. So if you're making things, you might consider a factory pattern. When you create things, we have creational patterns. Okay? So certain things happen. So we create things in a particular way. We've already seen some design patterns, or at least one very specific one that we looked at. Do you remember which one it was? Anybody? Starts with P, ends with Y, XY. Proxy. We actually did a proxy pattern. And there are different types of proxy patterns, but we did one specific proxy pattern. Remember how we did it? We had our proxy pattern by having the object was inside another class. So the class that the real class, the rational class, was hidden inside of sort of a wrapper class. The wrapper class had a pointer to this rational object. And then it did a very clever thing by overloading a couple things. It overloaded the parenthesis operator, creating kind of a functor, which means that you call, the client was calling a function, and then the function was giving you back a pointer. Okay, so that's how we solved that one. And what that allowed to happen is that anything you wanted that inner object to do could be filtered, or could be assessed, or could be determined whether that's the right thing to do, or whether we're going to allow that thing to happen, or we're going to count how many occurrences of that object. So we're able to control that access, rather than just give you an object and say, go ahead, use the object whatever you want. We're going to use that object in a particular way. So, critical step in designing object-oriented software is discovering the objects, and that means, of course, discovering the classes. There are various techniques that help us. Some of them are called use cases, and I would get into that in a little more detail in software engineering class, which I did if you had taken my class. Collaboration diagrams is another type of UML technique. Class responsibility collaboration, CRC cards, is another technique. But discovering the objects is still the hardest step for inexperienced designers to get right. We want to make sure that we develop enough classes, maybe not too many classes, and we structure them the right way. Lack of experience or guidance can lead to too many objects with too many interactions, and therefore a lot of dependencies. Typically what we want is we want to create a class. Each class that we create, and this is important, should have what we call a responsibility. Each class has to have its responsibility. And the responsibility of a class is basically what is the objective of the functionality of this class. What is it supposed to do? Does it have a purpose? And if that purpose is 10 things, then probably that's not a class. A class responsibility should be something that you can clearly state in a sentence. If it takes you a paragraph to state, then you're describing too many responsibilities, probably too many things. Now, if a class has a single responsibility, what is the purpose of the methods of the class then? What is the purpose of the methods? Any idea? So go ahead.
They're supposed to add properties to the objects.
Okay, yes. So the purpose of the methods in manipulating the properties of the class is to faithfully execute the class's responsibility. So the class has a responsibility to do something. So the methods are really there as support of those responsibilities. If a class has a responsibility that's clearly singularly stated, and you have methods that don't really line up with that responsibility, then maybe this is not really the responsibility of the class. Maybe you should reassess this class. So the method should clearly support the responsibility of the class. That's very, very important. So, in a sense, with design patterns, we come up with classes that have been tested, have been implemented over and over again by experts. The patterns document the expertise of other designers who decided, hey, you're doing this over and over again, here's a good way to do it. Okay? They describe how software is structured. More importantly, they describe how classes and objects interact, especially at runtime. So when I talk about runtime, we're talking about dynamic design, what's going on during the program execution at runtime. When we're talking about statically creating classes, that's sort of the design of the static view of the classes. Here's a class, here's a subclass, here's some methods. Okay? You're looking at structure and class. It's a static view of the classes. Dynamic is how they are executing or interacting at runtime. Okay, so taking these interactions and consequences into account of our design leads to a more flexible and reusable software design. Okay, so when would we not use patterns? So if you're going to use patterns, design patterns properly, it results in reusable code. The consequences often include some costs as well as benefits. Reusability is often obtained by introducing encapsulation, indirection, and abstraction. Indirection, encapsulation, and abstraction, which can decrease performance and increase complexity. So we are going to pay a price for this. Okay, it's going to take a little more time to do things using design patterns, but hopefully it will be more reusable. Hopefully it will be more tested. It will be a better, stronger design. All right, so let's look at the types of design patterns. For some reason, only 2 of them are highlighted. But really, all 3 of them should be highlighted. So the first design pattern we have is called the creational design pattern. And pretty much, it is what it is. A creational design pattern is a design pattern when we are making objects, when we're constructing objects. Very, very simple. So creational design pattern is a way that objects are created or constructed. So we are going to look at a set of patterns that support this model. So creational means creating. We are constructing. Structural design pattern is the way the data is organized into classes. And what that means is we're really looking at the static view of class design. How are we designing the classes? How are they fitting into each other? How are they connecting to each other? What does the class static architecture look like? And the last class we're going to look at are behavioral design patterns. So now behavior is what things are happening at runtime. So behavioral design patterns is what happens, the rules of what happens, how it happens, when methods are invoked or certain events are occurring. So behavior design pattern means that we are dynamic. It's the runtime behavior of classes. This is the static behavior of classes. This is kind of behavioral, but a special behavioral case at construction time. Okay, at creation time. All right, so let's talk about some creational patterns. These are very famous patterns, and there are, I forget the exact number, but there's a very nice classical book written about design patterns. I believe there's something like, I forget if it was 38 or something like this, patterns that they initially came up with that I thought were very good ideas that have been sort of classic patterns. So I'm highlighting some of them. So we're not going to cover all design patterns, but we're going to cover design patterns. So once you understand how the basics of design pattern works, you can certainly easily understand other patterns because you understand what the purpose is. So the first thing is, how do we create a class which is called a singleton? So a singleton class is a class that you only want to build one instance of a particular object. So normally, if you have a class and you have a constructor, then clearly, as a programmer, I can link to that library and construct as many objects as I want to by simply saying new, 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 or just using the constructor in parentheses and having a lot of default objects. How many is the limit? There's no limit. But what if you want a limit? Now, why would you want a limit? Any idea? Why would you want a limit on a number of objects we create? What might be a purpose of creating only a single instance of an object?
It's unique. It's unique.
it's unique, or maybe it's also accessing unique, what? Unique resources. Okay,
Like there is connection.
was that? Say again?
Like there is connection, for example.
Yeah. So this singleton class, basically we only want to create one. So how do we do it? So now it's like, well, the boss says, okay, we have to just define this class, and we're gonna have this class, but we only want one instance of it. So, well, how am I gonna do that? Oh, geez. So, well, it's a good thing I took this class to talk about design patterns, because there is a pattern called singletons. Apparently, this is more common than we think. So singleton classes require a private constructor. That's part of the pattern. You don't make the constructor public, you make it private. So you might say to yourself, well, geez, you make it private. Nobody can construct anything. The old way. And then you add a public static method which can return an instance of the existing singleton object or construct the object if it doesn't exist. So the static public method can be accessed. And because the static public method is accessible by anybody because it's public, it can access the constructor because it's in the class of the constructor. So as an example of code that we would look something like this. So obviously a very good name for the class probably is not singleton. I'm calling it singleton only because it's a singleton class. So I thought that would be appropriate. But it could be anything. It could be, my, HTTP connection. Whatever it is, you only want one of those things. So the first thing we do, we move our constructor directly into the private area, which means that no longer clients can construct this. In fact, nobody can really construct this, except the class itself. And then we're going to add into this private area a pointer to a singleton. Okay? So as a private property, we have a pointer to a singleton. And we're going to call it instance. Okay. And then we're going to have a destructor here. And then we're also going to have a public static method called getInstance. Anybody can call getInstance because it's a static method and it's public. And it will return a singleton pointer. Normally, when I say new singleton, it would return a pointer to a singleton. But I can't do that anymore because now the constructor is private. Ooh. So now, I guess that's it. So I don't have the code for this, but let's talk about the code. So I thought I had the code there. So what we're going to do is we're going to code this method called getInstance. So anybody calls getInstance, right? So I have a client, and the client says pound include singleton.h. They got the header file. Then we're going to have a CPP. So let's look at how the CPP is going to implement. So what's the code going to look like? What is the code going to look like? getInstance. On the very first call to getInstance, there will be a first call, second call, third call, fourth call. When the call is first made, what do we want to do? We don't have an instance. So we're going to check. So the code here is going to say if
instance returns no.
So somehow we need to have a null value, right? So we're going to assume that this value is null. It's going to have to be null. So therefore, we're going to say that the instance method is going to check if instance is equal to null. Is instance equal to null? What does that mean?
Call the constructor.
Okay. The instance is null, then what we're going to do is we're going to call the constructor, we're going to say instance is equal to new singleton. Right? Close our conditional. And then we're going to return instance. On the next time we're going to call getInstance, what's going to happen? The condition is going to be the condition is going to be false because instance is not going to be null. It's going to be set equal to this value. So in this case, we're going to skip the new call, and we're going to simply return. singleton. Can you see, so you see that's the basic design pattern. It's pretty simple, but it's very useful. How would we modify this pattern? Let's say somebody said, okay, we need to create not a singleton, but we need to create a class so that we can have 3 objects created.
The counter?
3 objects created, and you can never allow more than 3 objects to be allocated.
If condition, init condition grade less than 2.
So we need to, number 1, we need to create an array
Yeah.
of 3 instances. We need to basically keep track of which instances have been, so the first time we construct instance 1 and we give it up. Second one, we construct instance 2 and we give that out. Third one, etc. What happens to the fourth one? The fourth one, we might return null because all 3 are out. So we're also going to have to require a method which is going to be get instance and then return instance. Does that make sense? So you could see how you can modify this pattern to do something that's similar to this, but has a little bit more flexibility. If you want more than a singleton, maybe you want 3 copies at the same time. Maybe you want 2 copies at the same time. Maybe you have a return method and you don't give the second copy, you don't get that copy out if the first copy is out. It's a singleton, but if somebody's using it, they have to return it. What if they don't return it? You have to. There are ways of, you might want to find out, well, when's the last time they used it? Could we find that out? Well, we could find it out if we build the object to keep track of each time it's used, it's going to be date stamped. That would require what kind of object? What kind of object would date stamp it every time it's being used automatically without the client doing anything? We've talked about that before. What kind of an object does something automatically whenever it's being accessed? Proxy. So we might need to combine a proxy and a singleton, for example. Okay. All right. So let's go to the next creational pattern. So singleton, anything I talk about, you really should do a little more research on it, and then next week, I'm going to have you guys do some in-class labs with design patterns. That's what we're going to do, so get ready to code next week. Okay, we're going to cover them this week, next week we're going to cover them. Okay, so prototype is a way to create a new object where copies or clones of existing objects are being made. So the prototype pattern is a creational pattern used when the type of objects to create is determined by a prototypical instance which is cloned to produce new objects. Some newer languages, newer than C++, have this prototype built in. In fact, many of the prototypes we're going to look at, because they're old and they go back to the late 80s, early 90s, a lot of them are implemented as part of the standard of languages, like in C# or in Java, for example. One of them is in Java, for example, there's something called a clonable interface. The clonable interface in Java requires the clone method to be coded. Well, we have to have a clone method here. So to implement the pattern, we declare an abstract base class. You're going to see that this is going to be happening over and over again. And an abstract base class requires what? At least what? An abstract base class requires at least what? At least one abstract, which means what kind of class? What kind of method? Pure virtual method, right? So it's going to have an abstract base class specify a pure virtual clone method. Okay? Any class that needs a polymorphic constructor capability derives itself from the base class. So we will have subclasses of this abstract class, and they will implement the clone method. Very straightforward. So here's an example of a class called product. Now there's no such thing as a product. A product is an idea, something you're making, something you're selling, right? So you have a product. Okay, so now you want to make product, you want to add product, something like this, and then you're going to have this clone method. And the clone method will be pure virtual. So now what you're going to do is you're going to create our subclass. This is a subclassing UML. What's UML stand for? UML, Unified
Modeling.
Modeling
Language.
Language. UML, Unified Modeling Language. This is a diagram using UML type diagrams. And this open arrow pointing up with the solid lines here shows inheritance, subclassing. Okay, so product one is a product subclass. And what is this over here? This is the clone method override. That's all it is. It overrides the method, overrides the method, overrides the method. So here you can see how we can create the abstract class. And so the prototype is simply a C++ class. We might have some type, some value, properties, whatever we want. And here is, notice that even though I have type and value, I can have specific methods that are actually well coded. So get type, get value is coded. There's a print method that's coded. But there's one method here, which is clone. And this method is virtual and it's pure. So it's pure virtual method, returns a pointer to a prototype. So now this class cannot be instantiated, but it can be subclassed. So concrete 1 and concrete 2 are both subclasses which are going to extend or subclass the prototype method. It's a public subclass, which means that they are going to show all of the public methods, right? What if I did private prototype?
It will not be accessed by all the methods, just one.
If I did a private prototype, could I still subclass this? Could I still override this, I mean?
No.
Yes, I could. Yes, I could. Remember, what I said a long time ago is that the way you subclass does not affect the direct subclass at all. So I could still do this. Now, what am I doing here? I'm actually overriding. So actually, I could say private prototype or nothing prototype would still be private. I said nothing is private by default. Okay, so I could. But what I'm doing here, and basically, I am giving the type value a specific name. A type is equal to type 1. Value is equal to some number from the constructor. And then I have prototype pointer clone method return new concrete 1 star this. What is this? What am I doing? What does it mean new concrete 1 star this? How am I? Give me a better name for what I'm doing.
Cloning it. Creating a new object. with-
I am, but give me something that we know what this is. What is this? What kind of method is this?
Concrete.
It's a constructor, isn't it? Do you see it coded anywhere?
Right there.
No.
No.
It's not coded. Why not? Because star this is what type?
Okay.
Concrete 1. And you don't see any concrete 1. So, what kind of constructor am I calling? I'm calling a copy constructor. But I didn't code the copy constructor. Do I have to? I don't have to code a copy constructor, because if I don't code one, what happens?
Rolls on by default.
I get a default copy constructor which does what? What does a default copy constructor do? I just inherited type and value, right? Right?
Yep.
Okay. So what does the copy constructor do? It creates an identical copy of this one, assigning the same values for properties. What doesn't the default copy constructor do? When do we want to create our own copy constructor? Also known as, what is the limitation of the copy constructor? Anybody? What is the limitation of a copy constructor? What doesn't it copy by default? The answer is, it doesn't create anything that has been allocated dynamically through the heap. So if an object contains any kind of pointers to objects that it allocates from the heap, you are not going to allocate more objects from the heap. You're going to copy the addresses to the heap of your object into a clone, which is very dangerous, because you will actually have pointers to the same thing. And two different objects, their pointers will be different, but they'll have the same value, so they'll be sharing memory. So we always want to create our own copy constructor if our data is going to be dynamically allocated. But as you can see here, our data is not dynamically allocated. We don't have any pointer stuff data. We just have a string and a value, an int value. So those are not dynamic, those are going to be statically allocated. What about the string? What do you think? Is the string going to be static or is it going to be dynamic? Is it going to create another string? You better think about it, otherwise you'll be sharing a string. All right, so that's what we're going to do here. Now notice the second class is also a prototype subclass. It's a different class. It takes a number and the value is always going to be type property that we inherited gets type 2. Value is going to be number, and we also override the clone method. So this is the basic kind of prototype design pattern. So we're able to manufacture copies of ourselves by creating this clone method. But again, the clone method, this is the easiest way to do a clone method, but it's not always the best. So the best is if you're going to actually create your own copy constructor. Can you tell me, if I were to create a copy constructor that did exactly the same thing as this is doing, what would it do? I would have to say concrete 2, and then I would say what? What would be the parameter for the copy constructor? Concrete 2, what would be in here?
Value.
You forgot already. Const, concrete 2, reference, and then what would it do? What would the code look like? Const, concrete 2, reference, R for ref or ref, and then we would say type equals ref.type, value equals val.value. Does that make sense? That's what that default copy constructor is actually doing. It's actually assigning into the properties of the newly created object the values of the parameter object. The parameter is this. So we're constructing a new copy based upon us. But we're allowing this default copy constructor to work. Okay, well that wasn't that successful, so you have to really think about this one, prototype pattern. Okay, so here's an example of a prototype test. So we're going to create a prototype pointer array called object array, and then we're going to create a prototype object pointer. So the first thing we're going to do is we're going to say object equals new prototype, object equals new prototype, star 2. So what is object? Object is really an array or a pointer to 2 prototype pointers. Object is an array or a pointing to a buffer of 2 prototype pointers. So then I'm going to say, actually, I think what I meant to say here, although it's still correct, I think I meant to say object array. So this should be really object array equals new prototype star bracket 2. They're the same type. But then I'm using object array 0, you see what I'm doing here, is equal to new concrete 1, 8, and object 1 is equal to new concrete 2, 64. Does everybody follow what this array contains now? So it contains a concrete 1 object and a concrete 2 objects, which are objects of different classes based on the same prototype. Then I'm going to just try to get a random number, and I'm saying random modulo 2, and it's going to give me 0 or 1. And based upon that value, I'm going to clone either object array 0 or 1 into objects. So I really don't know which one I'm going to get. That's going to be a surprise. And then I will say object sub 0 print, object sub 1 print, and object pointer print. Where's the print method? Do I have the print method? Yes. So I have print. Now notice that the print method, is it virtual or is it non-virtual?
Non-virtual.
Non-virtual. So it's going to, so basically they get the same method. So it's going to print type, get type, value, get value. So what do you expect the output to look like? Type equals, what's it going to print here?
Type 1.
Type 1, value equals 8. Type equals,
Type 2.
value equals,
64.
okay. And here, what do you expect?
One or the other.
Right.
It's going to look like either the first or the second. We don't know which one because of this randomness. Okay? All right. Next thing we're going to look at is we're going to look at a builder design pattern. So again, it's another creational pattern. We're going to build something. So we're going to have a builder. And of course, when we have a builder, we're going to have concrete builders. Concrete builders are builders that actually know what they're doing specifically. And then we're going to have a director. And a director is going to basically tell the builders what to do. But he doesn't know what he's doing specifically. Because directors don't usually know what they're doing. They just tell other people to do things and things get done. Right? That's the way it works. And I cannot tell over here. And I believe that's a product. Do you see product in there?
Yes.
Excellent, okay. So it's a product. So the builder has four main classes. The builder class, the builder class is going to be generic. The concrete builders are going to be specific. And then a director is going to basically invoke the builder, which will then be implemented by concrete builders. And we're going to build a product. So the builder is an interface, which in C++ means an abstract class, and it's implemented by a set of concrete builders. The builder interface sets forth the actions involved in assembling a product. It also has a method for retrieving the product, get product. The product object is object that gets assembled in the builder pattern. So the concrete builders implement the builder interface. Okay, a concrete builder is responsible for creating and assembling a product object. Different concrete builders create and assemble projects differently. And finally, director is the highest level class. It is responsible for constructing a product. It does this by calling the builder interface without necessarily knowing which builder it's invoking. So it calls the builder interface to access a concrete builder. It constructs the product using the various builder methods. Okay, so there are various uses for the builder pattern. If we'd like the construction process to remain the same, but we'd like to create a different type of product, we can create a new concrete builder and pass this to the same director. And the director will still ask for the same behavior, but the product will be a little bit different because we've modified the concrete builder. If we'd like to alter the construction process, we can modify the director to use a different construction process. So it allows us to make small differences. Okay? So the builder pattern is going to be very much like the factory pattern, which we're going to look at next. The main difference between the builder pattern and the factory pattern, which we'll follow next, is that the builder is useful when you need to do a lot of things to build an object. Whereas the factory pattern is kind of, it's relatively straightforward what you're doing. Okay, so let's take a look at some classes. So we have a class wheel, a class engine, and a class body. So we're going to create three classes, wheel, engine, and body. And we're just going to give it at least a property so that it makes some sense. So wheel has, for example, a size. An engine might have some horsepower, and a body may have a shape. For a car, let's say it's going to be, let's say, a sedan or SUV or something like that, or convertible or whatnot. So now we're going to have the car. That's going to be the product. So the car is made out of the pieces. So we're going to have an array of four wheels, if you will, an engine and a body. Notice that in C++ here we're basically using pointers here. So we have an array of four wheel pointers, a pointer to the engine, a pointer to the body. And then we'll have a print method which will basically say, okay, the body is, and then from the body we can follow and say what the shape is. The horsepower is, we'll follow the pointer to the engine, get the horsepower property. And the tire size, wheels, choose one of the wheels and give the size. Hopefully all the wheels are the same size for a car. I think that's probably a good idea. Although I've seen otherwise. But I think I've been watching the New York City Auto Show. It says some cars with some crazy wheels. All right, so that's the product. And here's going to be the virtual builder. So the virtual builder is going to be subclassed by actual builders. So the virtual builder basically is going to produce these pieces. So builder will return to you a pointer to a wheel, a pointer to an engine, and a pointer to the body. Notice that all the methods for the builder specifically are pure virtual, which means that we have to subclass the builder. Okay, so let's skip to that and we'll come back over here to the director. I think it makes more sense. So basically we're going to create a class. Let's say we want to create a class called Jeep Builder. We want to build a Jeep vehicle. So we're subclassing or extending the abstract builder class. And then we're going to implement these methods that were pure virtual: get wheel, get engine, get body. Notice that they return the proper types. So to get the wheel, we're going to say wheel star wheel equals new wheel. And we have that class already. We saw that. And we'll go to wheel pointer size is equal to 22. Now again, you say, well, how can you access directly to the wheel, the size? Isn't that kind of a violation of class encapsulation? Maybe. Or maybe if we want that to happen, we can make that class a friend. I just don't want to overcomplicate things. But at any rate, so the get wheel method will create the wheel, it'll set a parameter for the wheel size, and it will return the wheel pointer. Okay? Engine, similar kind of thing. We'll construct the engine, set the horsepower, because the concrete builder knows that a Jeep, and again, I'm simplifying things, it could be a Jeep model, whatever, but it knows that a Jeep requires a certain kind of wheel, a certain kind of engine, and a certain kind of body. Okay? And of course, we're going to have another builder could be a Nissan builder, so maybe that's going to be a sedan or a hatchback. In this case, the wheel is going to be, again, we're going to construct the wheel, set the size to a different wheel size, return that. For the engine, again, we're going to make the engine a little bit weaker, return that. And for the body, we're going to create the body and set its shape to hatchback. So that gives us, and of course we can create more of them. So now we have two builders, and here is our virtual builder. So now we're going to look at this director. The director is going to be sort of driving this whole process. So the director will get a pointer to a builder. Okay? And then, so once you get a pointer to a builder, you can actually have another method called set builder. So if you want to put in a new builder, you can put in a new builder to the director. So the director basically knows what is the process of putting the car together, how to build the car, without actually knowing how to build the car. It knows what needs to be done. Okay, so the builder basically, so for the director, you say to the director, I want to get a car. So the director basically has a builder that's going to do the job for it. And the builder will access the director will access the builder only through the abstract interface. Because if you think about it, we could set the builder to a Jeep builder or a Nissan builder, right? Or a Mustang builder or a BMW builder, or whatever we want to have. And all of them are going to be subclasses of the builder. Remember, this builder is not a concrete builder. It just says builder, like this, right? And the builder is not a concrete class, so therefore we're having a pointer to a not concrete class. But the reason that can happen is because the Jeep builder subclasses extends builder, and therefore it is a builder. And that's why that works. Because we can set a Jeep builder or a Nissan builder into particular builder reference for the director. Once the driver program says, I want to get a car, okay, then it's going to, so the director will simply, you can call the get car method from the director. So the director will construct a car, and then it's going to have to put the body on it. So it will ask its builder to get the body. And of course, the builder will be a specific builder. So therefore, if it's a Jeep builder, it will do it one way. If it's a Nissan builder, it's going to do it another way. But every car needs a body. So therefore, that's sort of the common abstract behavior that a director would know. So it creates a car, gets a body, it gets an engine. The director also knows that cars require 4 wheels. Okay? So therefore, it's going to go to the builder and get a wheel, and another, and another, and another. Once it does that, it has essentially set all the properties into the car, so it can then return the car, okay, which is nothing more than a car pointer. So that's what the director does. So these are the concrete builders, and now we can test the pattern. So the pattern will look like this. So we have a pointer to a car. We're going to construct a director. So if we construct a director, notice that there is no default constructor for a director. Right? We probably should have one, but we don't. So the next thing I'm going to do is I'm going to construct a Jeep builder and a Nissan builder. So now I'm going to output Jeep, and I'm going to say director, set builder, and I'm going to set the address of a Jeep builder. Remember, it's expecting what? A builder pointer. So a Jeep builder address is a pointer to it. And then I simply say director, get a car, and the car is here. I'm going to print it. What's going to print? It's going to print the Jeep car, right? Okay. So now I'm going to say, I'm going to output Nissan, and I'm going to go to the same director. I'm going to set the builder. This time I'm going to give it the pointer to the Nissan builder, which is the concrete Nissan subclass of builder. I'm going to say director, get car. So notice the get car here is returning a Jeep, but here it's returning a Nissan, because that's the builder that's been put into there. And I print the car. I don't know if I have the output here or not, but don't have the output. You have to imagine that. You can run them yourself. And actually, you probably should run all of these that are coded. So when you come into here next Monday, you guys are going to be like, okay. Any questions so far? So how many creation patterns do we see so far?
3.
Singleton. Prototype. Builder. So now we're going to look at factory. I have 2 examples of factory. I'm only going to go through one of them. All right, so factory. So factory again. What does the builder do? It builds things. What does the factory do? Well, it also builds things. Well, that makes sense because it's a creational pattern. So a factory is a class that's used to encapsulate object creation code. Maybe it's a little bit simpler than builder, similar. It returns a particular type of object based on the data passed to the factory. So it's like this. So you tell the factory, hey, I want to get, I'm not going to go back to the same car example. I'm going to say, let's say I want to get a toy train. So the factory makes a toy train for you. I want to get a yo-yo. It gives a yo-yo for you. I want to get a toy truck. It's a toy truck for you. So the factory basically can do that. We tell the factory what we want. And the factory then, based upon our input, does different things to produce different objects. So if it's going to be a toy factory, then I guess the product that we're going to be producing is going to be a toy, right? It's going to be a toy. But a toy cannot be a concrete class, because we have to be able to produce any toy. So we want to produce any pointer to any toy. By the way, one of the things I want to make sure that you understand strictly with C++, very, very important thing. So let's just think for a second here. Let's suppose we have a superclass, because all of these design patterns are having these abstract superclasses. But superclasses don't necessarily have to be abstract. So for example, let's say I had a class, let's say this class is going to print, I am a superclass. Okay, then we subclass this one and we override the print method and it says I am the left subclass. I don't know why left, but I'm going left, so it's going to be left. And this one overrides the same print method and says I am the right subclass. Okay? So now, are you with me? So we have a superclass, we have the left subclass, we have the right subclass. This one says I am a superclass, I am a left subclass, I am a right subclass. So now we're going to create an array of superclasses, objects. Keep in mind that we have an is-a relationship. So the method takes as a parameter a pointer to the superclass. But by inheritance, an array of left subclasses is also is-a array of superclasses. Right? So I pass in the array of left subclass objects. And I loop through them in the method calling the print method. What do you expect the printing to say?
Left subclass.
You might expect left subclass. Anybody expect right subclass? Probably not a good guess, right? So either left subclass or superclass. So which one is it going to be? Well, I probably didn't give you enough information to answer the question properly. I'm going to ask the question in a different way and see if you can know the answer to it. How would I have to pass the parameter in order for the parameter in the method to print left subclass? I am a left subclass object. I would have to pass, well, there are two things I can do. I have to either pass the array of subclass objects by reference, or I have to pass them by pointer. If I pass them by value, then any subclass is going to be assumed to be a superclass. Did I mention that before? I don't know if I did. I might have, but I think I might, maybe very briefly. What I mean by that, suppose I have a superclass going into a method, but I pass in a subclass object, which overrides the print method. If I pass it by value, then I will not have any polymorphism possible, which means that the method will execute the superclass method. The only way you're going to get polymorphism, and any way that C++ is going to look at the type of parameter that's coming in at runtime, is if you pass the parameter by reference or by pointer. So you either have to have a pointer to the superclass, in which case a pointer to the subclass will invoke polymorphism, or you have to have the base, the superclass by reference. Then you can pass the subclass object by reference, and that way you get polymorphism. If you don't have a reference or a pointer in the method, then the subclass will exhibit superclass behavior. And the reason for that is quite simple. Basically, it's not important what the reason is, but the reason the reason it's going to happen is the compiler, if it doesn't see a reference or a pointer, has no access directly to the actual object. Therefore, it cannot determine what the object is. Therefore, it says, okay, if you're giving me a value to a superclass, then any subclass is going to behave like the superclass. Okay, I just want to mention that because that may have that may influence some of the stuff that we're looking at right here. Okay, the different objects that are returned from a factory typically are subclasses of the common parent class. If I'm returning a bunch of toys, I probably would have an abstract class called toy or toys, sure. And then I would subclass them to specific toys. So I say, make me a train, make me a toy car, make me a doll, whatever you want, and that would be a toy, because the factory has to return the same type. So therefore, the type has to be abstract so that it can return specific types, all of which are matching that type using the is inheritance. So let's take I have another example that I'm going to use. So everybody is hungry, so I'm going to make a pizza example. Okay. So the abstract class is pizza, right? Everybody feel like pizza is good. Maybe I should make a Pepe's pizza and deliver it right here. That'd be a good idea. That'd be even better. That would be a winning scenario. But, so the first thing we're going to have is we're going to have an abstract pizza. If somebody says, hey, give me a pizza. Well, no, please, no, may I have a pizza? Here. Nobody, you cannot say to the vendor and say, I want a pizza. What are they going to say to you? What kind of pizza do you want, right? I mean, pizza is not a thing. Pizza is a type of a thing, right? When you go out for pizza, you can say, hey, you'd like to go out for pizza, then abstractly you're going out for pizza. But when you sit down at the table, you can't say to the waitress, we'd like a medium pizza. She goes, well, okay. She's looking for the concrete type, right? So that's the idea. So we're going to make a pizza which is an abstract superclass. And so we're going to have virtual int get price. Notice the pizza, we don't even supply a pizza constructor. Obviously you don't need a constructor because you can't construct it. But if you had some properties here, you could put a constructor here that could construct the properties that do exist. But clearly we cannot instantiate. Why would we put a constructor here? If we had properties that are public and then we had a constructor that's public, why would we want to have a public constructor? Who would call the public constructor? The subclass constructor. All right, so the subclass constructor could. So if you had properties here, the client couldn't call it. But if you subclass and made a real pizza, the real pizza could say, okay, now I'm going to superconstruct this one because I've already overridden some stuff. So the get price, I don't know how much a pizza is going to cost because I don't know what kind of pizza it is. So therefore, the get price is going to be a pure virtual method. And then I have a virtual constructor. Can somebody tell me what is a virtual constructor? We know what a destructor. Destructor. What am I talking about? Destructor. Virtual destructor. What is a virtual destructor? Anybody have an idea?
Requiring that the subclasses.
Sort of. If you don't have a virtual destructor, then any subclass will not call destructors if they declare them. So if you want the subclasses to call their own destructors, you have to create a virtual destructor in the base class. That's it. Nothing more than that. Okay, so now here are our hungry pizzas here. So we have a ham and mushroom. We have a deluxe pizza, and we have a Hawaiian pizza. You heard of Hawaiian pizza? How many people like pineapple in their pizza? There's always a few. Always a few. I'm not one of them. But my sons love it. I don't know what it is. All right, so basically, all these pizzas are public pizzas. Subclasses, okay? Now, notice that I have a price, and the price is going to return some cent value, so it's going to be $11.50, $18.99, $15.50, different prices. And then I will also have, at this point, a virtual constructor. Question for you, do I need the virtual keyword here? I don't need it at all. So the virtual keyword doesn't do anything for me here except that it says, oh, it's virtual. But it's not necessary because basically already get price is virtual in the superclass. So therefore when you are overriding it, it is a virtual method. And it's not wrong to have it. You don't need it. It's not wrong to have it. Maybe it's a good idea to have it so if somebody subclasses you, they can say, okay, it's virtual. Okay. But you don't need to have it. And likewise here, you don't need to say virtual here, but typically, people do it for clarity. So clearly we can see that there are three types of pizzas. So now we're going to have the best part of the pizza is the pizza factory, which is going to be our oven. And so the pizza factory is going to, when we create a pizza, it's going to return a pizza pointer. Here's your pizza. Follow it to this address. And the other thing we add to it, we add a public enum called pizza type, ham mushroom, deluxe, and Hawaiian. What's the value of ham mushroom?
0.
0. How about deluxe? How about if I said deluxe equals 3? What's the value of deluxe?
3.
3. If I said deluxe equals 3, it's 3. If deluxe equals 3, what's Hawaiian equal to?
4.
4. Okay. What if I say mushroom equals 1, deluxe equals 1, Hawaiian equals 1? What's the value of all of them? 1. Is there any purpose of doing that? No. Can you do it? Yes. In some cases it might make sense. Like maybe the cost would be equal 1, equal 1, equal 5. So maybe one wanted to do something like that, but whatever. Okay, so the pizza type is just an enumeration, 0, 1, 2, but implicitly. And now we have a create pizza, and the driver program will say, I want a pizza type, and the pizza type, for example, is going to be deluxe. So what I'm going to do to create the pizza, I'm going to do a switch. And a switch, let's say, on deluxe, it's going to catch that case, return new deluxe pizza. And of course, deluxe pizza is going to be this one. So it's going to construct this object. There are no properties, so there's not a lot of activity going on in the constructors, but they are default constructors. And the default constructor will default construct the superclass. Yes, it will. Where's the constructor? It's default. It's not there. We didn't code it. Oops, sorry about that. So therefore, when we construct the ham and mushroom pizza or deluxe pizza, it's going to super construct the pizza virtual base. All right, and then we will throw in an invalid pizza type in case we have some kind of a problem, and we'll have a problem in case the switch is going to be out of range. So I'll show you how that's being done. So we're throwing some kind of a string here. All right, so now we're going to go to get types. These are some helper methods. So we're going to have some helper methods like, for example, switch type. If you want to get the type of pizza, then now here is we are outside of the pizza factory, so we have to use the pizza factory class to get the pizza type enumeration. We switch on the type, case pizza factory mushroom, return ham. So this is going to return a string to the driver, because people don't want to say your pizza type is 0. Oh, great. People want to have some meaning. So pizza type, you're going to send a pizza type, which is an enumerated type 0, 1, 2, and I'm going to return to you a string, which makes sense. I'm going to also do a price format. So what I'm going to do is I'm going to define price format. You're going to give me a price in cents. I'm going to create double dollars, which is going to be price divided by 100. That really should be double, but anyway, it will be double. It works because this is just going to give me the integer value of dollars, which will then be promoted to dollars as a double. Fine, that works. And then for cents, what I'm going to do is I'm going to take the price modulo 100. So I'm going to take the last 2 digits of the cents. I'm going to cast it as a double. So it's going to be 89, and divided by 100. If I don't cast it, I'm going to get a 0. So if I cast it and divide it by 100, I'm going to get 0.89. So that's going to be the cents, and then I'm going to return dollars plus cents, and that's going to give me a nice dollars and cents value. And finally, I'm going to have pizza information, which will again take a pizza factory pizza type, and then it's going to go to the pizza factory, create the pizza of the pizza type. So this is the key method right here. We're basically invoking the create pizza from the pizza type. Here's the method. Notice the method is static, so I don't have to construct the factory, right? I can just directly out of it, I can go, so what I'm going to do, I'm going to go pizza factory, that's class name, create pizza. So I'm calling the method out of the class, because it's static, I don't need to instantiate the factory. Of course, if I wanted to make this create pizza a non-static method, then I'd have to say create the factory first, and then say factory object dot create pizza type. That would work also. So once I do that, if you give me a particular pizza, I will create it, and I will output cout price of get type pizza type, and that's going to be, so if it's deluxe, it's going to give me the string deluxe, is dollars, and then I'm going to use fixed set precision 2. Can somebody tell me what fixed and set precision 2 are? Those are called I/O manipulators, or I/O manipulators. Those I/O manipulators are from the standard library, and what it's going to do, it's going to be fixed point output, set precision 2. I want 2 decimal places, because sometimes I may only get 1 decimal place or 3 decimal places. I want 2. I want it to round if you have 3, and I want to extend if you only have 1, or if you have 0, I want you to give me 0, 0. So it's fixed. So this manipulates the output stream using I/O manipulators, which are really functors. More on that later. And then I'm going to go to the price format, which is my own method here, and I'm going to go to pizza get price. That returns the cents. This returns the double with the dollars and cents, and then an end line. And so this is the driver of the program and the output. Again, that's what we have time for today. So I'm going to show you some of the headers. So std accept, this is standard exception. So if you include that, you can throw exceptions at that point. IO stream, you get that one. String, because I'm using the string class. IO manip is because I'm using the set precision and the fixed format. I don't know why I'm doing that twice, but I'm doing it twice. And then I'm basically going to drive the program. I'm going to say pizza information. That's a method. And I'm going to go to pizza factory ham mushroom. So pizza information is going to invoke this method right here, which is going to create the pizza from the pizza factory based upon the pizza type that you're giving me. Sorry, here. And I'm selecting it from the enumeration from the pizza factory. So this is going to be ham and mushroom. So when I do that, this pizza information is going to create it and then do output of the type of pizza and a nice formatting of the price. And so you see it's going to be the price of ham and mushroom is $11.50. Okay, so this is going to be, this is my string that I'm returning from get type. This is my price that I'm returning from double. Okay? And then I say pizza information for pizza factory deluxe. And it's going to give me this price, and pizza information properly Hawaiian is going to give me that price. So that's a factory. Now, I'm going to just very briefly introduce what we're going to start with next time, and that is something called an abstract factory. What the heck is an abstract factory? Well, it's got to be an abstract factory. So first of all, what is a factory? Well, a factory is a class that creates things. And a factory can create different things. And you can see this factory creates 3 different types of pizza. That's fine. What is an abstract factory? So an abstract factory is similar to the factory pattern. The big difference is the factory itself is an abstraction. So you have to first get appropriate concrete factory before creating objects. So we have a level of abstraction. So here we had the pizzas were abstraction, and the specific pizzas were concrete, and then we had a specific concrete factory. Here we're going to have an abstract factory, and then we're going to have actual factories. So we just have one extra level of abstraction. So it allows us to create things more, so the factory itself can be different. And then you can give the abstract factory a factory to, for example, to make Sony parts, or make Sanyo parts, or make Samsung parts, or any company that starts with the letter S parts. Okay, that's it. I'll see you on Wednesday. So Wednesday we're going to try to finish up design patterns, and then we're going to have some nice labs on Monday and Wednesday next week. Maybe a little review, and then get ready for that big final thing.